Transport. All right, so passive. Let me just hear some characteristics of molecules that can do this kind of passive transport. Small. Non-polar. And those are two good ones, yeah, and uncharged. Now, if it's slightly larger, actually no, not large. Let's think about, just say, water, right? Water isn't, like, it's still kind of small, but it still has some polarity, right? So you use a channel, aquaporins, and that helps water go through. Is this selective or non-selective? Is this selective or non-selective?
Non-selective.
So ion channels still have to be selective, just like logically speaking, right? So yes, this allows water to flow down its concentration gradient passively, doesn't use any energy. But this inside, I've drawn it just as a line. If you go pull up any scientific paper that like characterizes the inside of these ion channels, super intricate. You have a lot of R groups poking into the center of this channel that creates like a unique path that only lets water flow through. So this is selective for water, and the same is for if you had a potassium ion channel or a sodium ion channel. They're unique to what flows through. All right. This is a transporter. Say that the molecule is a bit larger, say like glucose, right? And you still need to get it through passive diffusion, which occurs in your gut. You absorb glucose passively. It binds to this protein and then it gets shunted across. So there's like movement of this transporter protein. Does that use energy? No. So how is it moving? Correct. It's using a high concentration gradient. And this, if anybody ever, if that bothers them, the way that this transporter protein is able to bind glucose and then change its conformation and then shunt glucose to the opposite direction, it's because when the glucose molecule actually binds to the protein, the interaction of the glucose with the transport protein's groups, that interaction induces a conformational change. And that shunts the glucose through. And then once glucose is gone, it just reverts to how it was